G'day, this video will just explain some of the tricky differences about dilations, reflections and translations, so all of the transformations. What I'm about to show you is a really typical kind of question that people really get stuck over. So I just wanted to go through it fairly systematically so that people can understand it fairly well. So here we go. I've taken this from the A+ questions. So the graph of this, x squared minus x plus 1 is translated 1 unit to the left and then is dilated by a factor of a third. And then I think the next question I'm going to do after that is I'm going to say it's the same graph, but now it's been dilated by a factor of a third, and then from the y-axis, and then translated 1 unit to the left. So it's basically the same thing, but in reverse order. And I guess I just want to show you what happens, or how the differences, how it's different based on the order. So I'll do this first one, and then I'll show you the next one. The way that I like to think about these is I usually say that the graph, let's call the graph f of x, and I'm not sure if my pen's going to work very well, but let's give it a go. That's way too big. Hold on. Oh, okay, let's try that again. So what I usually like to do is call this graph here f of x, and then I like to change things based on the different things. So g of x is going to be the first transformation, which is the translation, and then h of x or something else is going to be the dilation. So f of x equals x squared minus x plus 1. Then I'm going to say g of x actually equals the transformation that happens to f of x. So it's translated 1 unit to the left. Okay, translating 1 unit to the left means that I alter all of the x positions. I guess that changes the y position as well, but the thing I'm changing is the x position. So I'm going to say that every point, every x value has now been moved 1 unit to the left, because the plus 1 means that we move it to the left, the minus 1 means we move it to the right. Okay, I could explain that a little bit more, but hopefully you can understand what I mean by that. Now the next thing that's going to happen, so that's g of x is that, and then the next thing that is going to, everything's going to be dilated by a factor of a third from the y-axis. So then what I'm going to say is that h of x, this will be the new function h of x, and it's going to be a transformation of a third from the y-axis based on g of x. So a third from the y-axis, again you need to probably go back to the original videos if you're struggling to understand this, but that will mean that all of the x values are altered, and so that will be g of 3x, like that. Okay, because a third from the y-axis means that we multiply everything by 3. So I guess my resulting graph, if I'll take it over here, h of x equals g of 3x. So if I want to find out what g of 3x is, it should be g of 3x will mean that it's simply f of 3x plus 1. Because every time you see an x, you replace it with 3x. Okay, and then if I want to find out what f of 3x plus 1 is, I end up doing this. So f of 3x plus 1 actually ends up being 3x plus 1 squared minus 3x plus 1 plus 1. Okay, now if I wanted to, I could expand all of that out and see what happens, but it says you do not have to simplify. It's only worth 1 mark, so they're just after the answer mark. What I might do is I might show the differences on the CAS calculator in a little bit, but for now I'm just going to go and have a go at the next question, which will be very similar, except it will end up being a completely different graph because we're doing it in a different order. Okay, so again, I'm going to go through the same processes. The graph of this is dilated by a factor of a third and then translated 1 unit to the left. So I'm going to say f of x equals x squared minus x plus 1. So g of x is now going to be f of 3x. Okay, and then h of x is going to be g of x plus 1, because that's that translated 1 unit to the left. Okay, so again I'll go over here. So if h of x equals that, then that would mean that g of x plus 1, every time I see x I replace it with x plus 1, that actually equals f of 3x plus 1. Okay, it's significantly different to the one that we had up here. In the one that we've got down here, it's dilated first and then translated, whereas up here the translation is actually dilated, and I'll show you that in just a second. So this one ends up being, every time I see x, I replace it with, I'll just put this here, I replace it with 3x plus 1. Okay, so now it's 3x plus 1 all squared minus 3x, sorry, 3, mistake there, oop, back on track, 3x plus 1 and then plus 1. As you can see, just by looking at these two things, they'll be completely different because the 3 will have to be squared, and then whereas up here, 3x is squared, and so you'll get a completely different result. Okay. Now what I'm going to do is I'm going to show you how this has an impact on the CAS calculator. Actually, what happens to it when we do the actual graph. So bear with me for a moment. Okay, here we go. Here's our graph: x squared minus x plus 1. And the most notable thing that I'm going to look at is the minimum point here, 0.5 and 0.75. So then the next thing I'm going to do is I'm going to transform it. I'm going to first do the first one, which was here. So f of 3x plus 1. So I can do f1, because that will take me back to the first graph, and then 3x plus 1. Let's just have a look and see what happens here. Okay, so you can see it's a lot skinnier, obviously, because everything has been dilated, and it's also been translated as well. Let's just have a look at the minimum point, just so we get an idea of what's happened. Okay, the minimum point is, okay, so the y value hasn't changed, which is, that's good because we probably knew that anyway, but the x value has changed. Okay, now let's have a look at the other one. What was it? F of 3x plus 1. So a different order of transformations, and it's not there. And the reason is because I didn't put it in right. I just put f, and I don't know what f is. I'm not sure what that is saved at. I need to put f1. And see, there you go. You can see that it's all getting a little bit messy now, but you can see that it is actually a different graph, okay, with a different minimum point. Let's just have a look at that minimum point. So minimum of this graph now, go there, and there we go. Again, the y value hasn't changed, but the x value has changed. So essentially the difference is this red graph here has been translated first, so translated 1 unit to the left over to about there, but then it has been dilated over to here. Okay, so that makes the difference. The pink graph, that one was dilated first, so it gets squashed into the x-axis, and then it has been moved 1 unit to the left. Okay, it makes a difference to all the points. So hopefully that's helped you to understand the importance of order of transformation. So thanks for watching.